Welcome to my virtual class. This is the 10th of April 2020. In this class today, looking at this topic 5, going to look at the science of atoms and the reactivity patterns. Under this topic, we will cover the following: description of the particles inside an atom of an element, distinguishing between atomic number and mass number, using relative atomic mass in calculating formula mass of compounds. Very important is the description of the reactivity series. Now let's look at how an atom looks like. The atomic structure. Inside the atom we have protons and neutrons inside the nucleus. So the protons and the neutrons. Protons, we shall be calling them P, and neutrons, we shall be calling them N. All of them are inside the nucleus, but outside the nucleus there is an orbit where electrons are busy moving around the nucleus. So outside we have electrons. Very important. So how many particles do we have inside the atom? We have neutrons, protons, and electrons. Very, very important. Neutrons and protons are found in the nucleus. Electrons are found outside the nucleus. Electrons orbit around the nucleus via a circular elliptical path called energy level. An atom can be represented as shown above. Let's look at this part. Z is the atomic number. Now, if you have a representation like that, where X is the atom, A is the mass number, and Z is the atomic number, then we'll be able to say that, for example, carbon with a mass number of 12 and atomic number of 6 means that it has 6 protons, because the atomic number is equivalent to the number of protons inside that particular atom. Magnesium has 26 mass number, that is a number representing mass number, and then 12 protons, which is the atomic number. But the number of neutrons, to get the number of neutrons, for example, here you're going to take 26 minus 12, you get 12 neutrons. Therefore, mass number is equal to number of protons plus the number of neutrons. Mass number is the sum of protons and neutrons. Very, very important. Atomic number is the number of protons in an atom. In a neutral atom, the number of protons is equal to the number of electrons. Very, very, very important. Mass number equal to protons plus neutrons, and the neutrons is equal to mass number plus minus protons. Very, very, very important. Very, very important here. The atomic number of an element is also the number of protons and help us to predict the number of energy levels or electronic configuration of a given atom and hence draw its atomic structure. Dots and crosses represent electrons in an atomic structure. We want to draw the structure of lithium, but before then, let's look at something interesting here. The atomic number of an element, a number of protons, help us to predict the number of energy levels or electronic configuration of a given atom and hence draws its atomic structure. Can help us draw the atomic structure. Dots and crosses represent electrons in atomic structures. Let us start drawing this. Lithium has an atomic number of 3. So lithium is actually atomic number 3 and mass number 7. That's how it looks like. And we want to draw, we use these 3. So the arrangement will be the first energy level will always take 2. But let's have the nucleus first. Then the first energy level now comes out of the nucleus is going to take 2 electrons. 2 electrons. Be moving around like that. Then the last energy level, now from 3, because it has taken 2, it remains 1. That is lithium. Very, very, very important. Very, very important here. We call this the atomic structure of lithium. Back to our representation, let's look at sodium. Sodium is atomic number 11. Want to see how we can be able to draw sodium. Sodium is atomic number 11. So what do we do? First, we must be able to know that this is sodium 11, 23, looking like that. So we're going to use 11. Therefore, inside the nucleus we have sodium. Then the first energy level will always take 2 electrons. I do it badly here, but don't worry. Like that. The second energy level will always take 8 now, if there are more. This becomes 2, 8, 1. So that it gains up to, add all of them, we get 11. So this one will take 8, 1, 2, 3, 4, 5, 6, 7, 8. You can distribute them uniformly like that. Then this remaining one electron to take the last energy level as taking 1 here, and this is sodium structure. This one was lithium. Good. So moving on like that, we'll be able to use the periodic table to draw the atomic structure of the following elements: magnesium, aluminium, sulfur, oxygen, chlorine, neon, calcium, carbon, nitrogen. And there's a notification here that the third energy level takes a maximum of 8 electrons. For example, calcium has its atomic number 20. So the first one will be 2, the second 8, the third 8, and the last one 2. You can do your work, then post. Let me have your work done and return your work. Return your work, please. If you don't know how to post your work back, please send me a short text message on 07 488 217 15. 488 217 15. 07 488 217 15. My name is Omeri Tobias.